Okay, so I'm going to solve this sheet so that you can watch it and understand the process. So I'll be starting with the easiest sorting algorithm here, which is the selection sort. So we have seen the animation for this during the class hours, and the idea behind the sorting is simple. So in the very first step, you are sorting through the entire array. So you go from index 0, which is your first element, to the last element. You figure out whichever element is the minimum, and you swap it with array of 0, with a of 0. So this will ensure that your smallest element moves to the 0th location. After this, your 0th location is fixed. Then you take the remaining of your array and iterate through the index 1 to n minus 1. Forget about 0. So find the minimum element in this particular range, and once you find it, you can just swap that with a of 1. So after this particular round, your first element is also fixed and you don't need to touch it. So that's how it's going to sort through the entire array. The same process is described here round wise. So you can go through it. So in round 0, you are going to go from 0th index to n minus 1, and 0th element will be fixated. In round 1, you go from index 1 to the last element, and your index 1 element will also be fixated after this, so on and so forth. So of course, you're going to have roughly n rounds because there are n elements. So let's try to fill this table here. So don't get confused by this table. It's helping you to see how the values are going to change for your outer loop and for your inner loop. So your outer loop is usually represented with the variable I, and your inner loop is usually with the variable j. So your outer loop is responsible here in this case for telling you till which index are you sorted, right? So after the first round, this element will be fixed. After the second round, both of these elements will be fixed. And how you fix them is the inner loop. So let's see. So in the round number 0, which is the round after which your 0th element will be fixed, right? So let me write down after this particular round, your 0th position are going to be fixed. So you can say index or position. Oh, it's the same thing. And range of j here means it depends on how you are going to fix it. So your I is 0. So j is going to go from your element a of 0 to the last element a of n minus 1. Figure out which is the minimum and then swap that with a of 0. So j is going to go from 0 to n minus 1 in the very first round, and then you swap, and then come the first round. In first round, a of 0 was fixed, so now this time j is going to go from 1 to n minus 1, index 1 to n minus 1. Find the minimum, swap it with the index 1 location. So after this round, position 1 will be fixed. After second round, position 2 will be fixed. Similarly, after ith round, position I will be fixed. So far so good. Now, next question, when are you going to stop? So, we are going to stop when, obviously, you can say the last element is fixed, or we can be a bit smarter here and we can say the moment you fix the last second element, automatically last one is also fixed, because you are saying the smallest element is here, second smallest is here, third smallest is here, so on and so forth. The second largest will come here, and by the time you have done that, obviously the largest element is the one which will be remaining at n minus 1. So you can slightly optimize it, and instead of going till all the n minus 1, you can say that as soon as the location n minus 2 is fixed, we are done. And in which round is that going to happen? So we know that through this table, it's very pretty straightforward. 0th position is fixed in round 0, right? So n minus second position is going to be fixed in the round n minus 2. So from here you get the range for I, which is going to go from 0 to n minus 2. Now, what's the total number of rounds? You have round 0, round 1, round 2, so on and so forth. We plan to go to till round number n minus 2. So please note that total number of rounds is not n minus 2, it's going to be n minus 1 because you are starting with a 0 here. This gives you the outer loop, which is responsible for how many rounds are there. So I goes from 0 to, so be careful here. I have a less than equals to. So we are going from 0th round to n minus second round. So again repeating I here, this outer loop, it is responsible for telling you what is the round number, or you can say after this particular round, which index, till which index your array is fixed or sorted. Now, inner loop idea. Inner loop is the loop for j, which is responsible for iterating through the array, finding the minimum and swapping it. So, what's going to be the range for j here? So, we are looking for a generalized formula here. Is a slight typo here. So, it's not using n, it's using I, right? So you can see very clearly here j is going to go from 0 to n minus 1, 1 to n minus 1. So in the ith iteration it's going from I to n minus 1, and you can just put it here, j goes from I to n minus 1, finds the minimum and swap it. Now you can use this idea to fill through this code. So we have called the selection sort function over here. Now, please note that whatever changes you're going to do in the selection sort function, they will directly happen to this array, because we have discussed this multiple times. When you pass an array as an argument to a function, it's passed as a pointer. Whatever changes you make to the array, they will be reflected in the original array. The same thing do not hold for this value n, because it's a simple integer. So here it will be a different n, and in case you make any changes to the variable n, it will not be reflected in the original code. So leaving that out, how are we going to fill this code now? So we have seen most of it above. So we already know that I was responsible for the rounds, and our rounds were going from 0 to n minus 2. Now be careful. You can either say I less than equals to n minus 2, which is same as I less than n minus 1. So since there is a less than over here, I'm going to write n minus 1. You can also write the same condition as I less than equals to n minus 2. You won't lose any points for that. And this is the inner loop. Now this one. And now this one is responsible for finding out the minimum element, but you have to find the minimum element in the range from I to n minus 1. So the j is going to run from I and going to go till n minus 1, which can be written as j is less than n. During all this time, you have to find the minimum, and I hope you already know how do you find the minimum in an array. So j goes from the index I up to index n minus 1, and it is supposed to find the minimum element in this range. So your min index should start from I here. That means you look into this element first, then this element, keep on going and maintain a minimum. So as soon as you find an element which is lesser than the element over here, your min index becomes the index of that element. So that's the common logic behind how do you find minimum. So min index equals to j. By the time you are done with this loop, you would have found the index of the minimum element here. So let's say you found a minimum somewhere over here, and let's say it is 8, right? So your min index will be 8. Next question is, what are you essentially going to swap here, right? Which two elements? So definitely the element which is at min index. So I'm going to swap the element which is there at so it should be ARR of min index. And with which element are you going to swap it? With AJ? Of course not, right? ARRJ is the same element. I'm going to swap it with the element which was here, because after this particular round, this is the element which is going to be fixed, and this one should be the minimum. We are going to swap it with ARR of I. You can write this swap function in multiple ways. In bubble sort, I have shown you a different way. Here, over here, it's a proper call by reference. So this is slightly tricky. Instead of passing the array itself, I'm simply passing the address of both of these elements, right? And now I have to swap them. So I'm passing the address of this location of memory and the address of this location in memory, and you're supposed to swap that. So we swap that here. Since it's called by reference, we are passing the addresses. So we need pointers to collect them. So roughly the idea here is so if this is your ith index and this is your min index that you found, this Pointer A is roughly pointing to the min index value. So pointer A is pointing here and pointer B is pointing here, and we want to swap both of these. Now there are multiple ways to swap. So we can use the most common way, which is the use of a temporary variable. So let me create a temporary variable, which is int t. So you get a t over here, and then you can place any of these variables into t. So you see, I can't write t equals to a or t equals to b. So I have to use a dereference operator here. So when I say t equals to star a, it's going to look at the value which is here. So let me also assume some values. Let's say it's 20 and let's say it's 25. So when you say t equals to star a is pointing to this particular location over here. So this value will come and sit into t here. So I have stored 20. So next what I can do is star a equals to star b. So by that what happens, the new value of star a is where b was pointing, which is 25. So this value becomes 25, and since these are pointers, the change happens directly to the memory. If it is confusing you, please ensure you come and talk to me in person. Although these are basic concepts that you would have seen in ITC, but I can repeat them for you if you meet me during the office hours. And the last part which is left off is I need to correct this value over here. So star b becomes equals to what was there in t. So this becomes equals to 20. So this becomes your swapping process. And that's all. I think the code for your selection sort is successfully over. So you can try to code it and check the results. Let's come to the final part, which is finding the complexity. So count for each round. And since we started with a round zero, feel okay adding a round zero over here. So let's say we have to see. So again, we do not worry about constants. We only worry about how many times steps are repeated, right? So in round zero, what was the number of j iterations? In round zero, j went from element 0 to n minus 1 and then found the minimum element. So j had to look over all the n elements in the array. So in round zero, you checked n elements one by one. You checked n elements, applied an operation there, some constant time or 2 nanoseconds, doesn't matter. You also did a swap after that, but swapping is constant time. So we are focusing on what is getting repeated here. And what is getting repeated here is going through going through each and every element of your array and using that condition. If this if your minimum is sort of less, if this element is sort of less than minimum, and trying to figure out the minimum index, right? So that's what is getting repeated. So in round 0, j had to actually do that step for n elements. In round 1, it is one less an element. In round 2, it is again one lesser than what was there in round 1, so on and so forth. Our last round was n minus second round, and there j will have to look roughly n minus 2 locations, right? So this you can also write it roughly. This actually depends on how you have coded it. So we have assumed that our last round was n minus 2. If you are making your last round as n minus 1, your values will change here roughly slightly, but overall your complexity will remain the same. So what's the total number of times this statement has executed? So this becomes n plus n minus 1 plus n minus 2. I'm sorry. So this should be 2 here. I'm very sorry. Why this is true? Because in our last round, we had two elements, right? N minus 2 and n minus 1. These were the two indices left. So you find the minimum in here. So you go up to 2, right? And then from here you can find the exact time expression. So we are assuming that whenever you are doing all these iterations, you are executing this if condition, which takes you a constant time. So this c is for that, but again this doesn't matter, it's going to evaporate because of our big O notation. So again what matters is if you could just simplify this summation. Now there are two ways of simplifying this. You can directly fit an arithmetic progression formula here. So it's nothing but 2 plus 3 plus 4 plus 5 all the way up to n. So if you remember the AP formula, so your AP formula was number of elements. So let me write that by mod E, just not to confuse that with n. or let's say number of elements n by 2, 2a plus n minus 1 into d. So you can use that formula here. So number of elements in this AP is from 2 up to n, which is n minus 1 by 2. A is 2 here, so this becomes 4, plus again number of elements is n minus 1, and your d is 1, and minus 1 by 2, and this becomes 2 plus n. So if you calculate it, it will become n minus 1 plus n into n minus 1 divided by 2. You can solve it completely, but the overall the point is you will get a term n square here, which will decide the shape of your curve, which is the highest order term. So if you want to write it exactly, let's actually do that. So this becomes n square by 2 minus n by 2 plus n minus 1, n square by 2 plus n by 2 minus 1. We can write that here, n square by 2 plus n by 2 minus 1. And again, ignoring all the constants here and all the lower order terms here, it becomes big O of n square. So yes, that's about selection sort.